A lot of IDP projects look impressive in a demo, then fall apart the moment real documents, real users, and real workflows show up. And when that happens, the business does not just lose time, it loses confidence in the entire AI effort. One of the biggest reasons IDP creates false confidence is that demos are usually built around ideal conditions. The documents are clean, the format is known, the pages are complete, the images are readable, the fields are predictable, the success criteria are narrow. The team is often trying to prove that extraction is possible, not that the overall business workflow is ready. That is why a demo can look excellent even when the production design is weak. If you feed a system a small set of high-quality sample invoices, receipts, or forms, and the values come back accurately, it is easy to think the hard part is done. But in real enterprise environments, the document set immediately gets uglier. Pages are cropped, scans are skewed, attachments are incomplete, versions drift, handwriting appears, supporting pages get mixed in. Different departments submit the same document in slightly different ways. And suddenly the system that looked smart in the demo starts producing uncertainty, exceptions, and rework. A weak team interprets the demo as proof that the use case is solved. A stronger team interprets the demo as proof that the extraction layer has potential, nothing more. That is a very important difference. A practical decision rule is this: a demo proves possibility. Production requires operational reliability. Those are not the same thing. If the audience is executive or managerial, this is where expectations need to be set correctly. A successful demo should create interest, not false certainty. If the audience is technical, this is where scope discipline matters. You are not just proving that text can be read. You are proving that the business can depend on the result. That is why demos look easy. They strip away the operational mess that production systems have no choice but to face. In production, IDP, extraction is only the first step. Validation is what turns extracted values into usable business data. And this is where many teams underestimate the real work. If a system extracts a date, an amount, an identifier, or a name, that value may still be wrong, incomplete, out of range, inconsistent with related fields, or inconsistent with known business data. In a demo, teams often stop at "the model found the field." In production, that is not enough. The business needs to know whether the field is valid enough to act on. Consider a simple operational example. A system reads gross weight, tare weight, and net weight from a receipt. A weak design saves the three values and moves on. A stronger design calculates whether net is consistent with gross minus tare, checks whether the numbers are plausible, and flags discrepancies for review. Or take a driver verification scenario. A weak design extracts the front of license name and date of birth. A stronger design cross-checks those values against barcode data, workflow metadata, and known records. Validation is where the system starts behaving like an enterprise application instead of a document reading demo. This matters operationally because bad data does more damage downstream than missing data. A visible exception can be reviewed. A silent error can flow into finance, operations, compliance, or customer-facing processes and create harder-to-find problems later. A practical implementation pattern is to separate confidence from validity. OCR confidence answers one question: how likely is it that the engine read these characters correctly? Validation answers another: even if the characters were read correctly, does this result make sense in the business context? Those are related, but they are not the same thing. Teams that skip that distinction usually discover the problem the hard way, after the demo. A production IDP system without exception handling is not really a production system. It is a fragile automation that happens to work when everything goes right. Exceptions are not rare in document-heavy workflows. They are normal. Documents arrive incomplete, pages are missing, values conflict, file types are unsupported, cloud providers throttle or time out, a job gets submitted twice, a file is unreadable, a validation rule fails, a low confidence field blocks downstream processing. None of that is exotic, it is normal production behavior. The mistake many teams make is designing as if exceptions are edge cases to be cleaned up later. In practice, exception paths need to be explicit from the beginning. What happens when OCR fails? What happens when the document cannot be identified confidently? What happens when required fields are missing? What happens when metadata and extracted values disagree? What happens when a job times out halfway through processing? A weak design either crashes silently, leaves the job in an ambiguous state, or pushes the problem to a person with no useful context. A stronger design creates explicit statuses, retry paths, escalation paths, and review queues. That means the system always knows whether the job is queued, extracting, validating, pending review, completed, retryable, or permanently failed. A practical recommendation is to define exception categories early: retryable technical failures, non-retryable technical failures, business rule failures, low confidence review cases, unsupported or ambiguous inputs. That classification helps operations teams, developers, and reviewers respond differently to different kinds of failure. This is one of the cleanest lines between demo thinking and production thinking. Demo thinking assumes the system's main job is success. Production thinking assumes the system's main job is success plus controlled failure handling when success is not immediately possible. Some teams talk about human review as if it were an embarrassing concession. As if true automation only counts when no person touches the workflow. That is not how serious enterprise systems should be designed. Human in the loop is often the honest answer to uncertainty, business risk, and operational reality. If a document contains ambiguous values, or if the business consequences of error are high, routing the case to a person is not a failure. It is a control mechanism. The failure would be pretending certainty where certainty does not exist. A realistic example is claims intake, onboarding, licensing, or compliance review. In these workflows, some values can flow automatically, but others need a second set of eyes because they are low confidence, high risk, or inconsistent with existing records. The goal is not to force human review on every field. The goal is to use people where they add value most. The difference between weak and strong human review is workflow design. A weak review process throws raw outputs into a queue and makes staff do detective work. A stronger review process presents the document, the extracted values, the validation failures, the confidence indicators, and the relevant evidence in one place. The reviewer sees what needs attention first, makes corrections quickly, and the system records what changed and why. That is not anti-automation. That is mature automation. This matters politically inside organizations too. If executives or department heads believe the only acceptable outcome is full autonomy, the project may overreach. If architects and delivery teams make human review a first-class design option, the system becomes safer, more credible, and easier to adopt. The right question is not, can we remove people entirely? The right question is, where should automation stop and where should human judgment begin? In production IDP, that boundary often determines whether the system earns trust or loses it. A 5-page clean form is one thing. A 1,000-page mixed record set is something else entirely. This is another reason prototype IDP often misleads teams. The document characteristics in production are often very different from what was tested. As inputs get longer, lower quality, or more varied, the problem changes. Long documents may require chunking, checkpointing, and page-level logic. Mixed packets may contain multiple document families in one submission. Low-quality scans may reduce extraction reliability. Handwritten notes, stamps, highlights, skewed images, and uneven lighting can make individual fields harder to interpret. Even if the OCR engine performs reasonably well, the workflow complexity rises quickly. A practical example is medical, legal, or compliance-heavy documentation. These sets may include typed pages, scanned copies, handwritten annotations, tables, inconsistent separators, and duplicate materials across hundreds of pages. In a demo, a team may test 10 clean pages and feel confident. In production, the document family becomes broader, noisier, and much more expensive to process. A strong implementation pattern is to separate workload tiers. Small, simple jobs should not be blocked behind large, slow, complex ones. Heavy jobs may need chunk-based processing, intermediate checkpoints, and more aggressive evidence retention. Simpler jobs may need high throughput and lower cost settings. Treating them identically is usually a mistake. Document complexity changes architecture, economics, and support needs. This is why production planning cannot rely only on sample accuracy metrics. Teams need to ask broader questions. How variable are the documents? How large can they get? How many supporting pages are involved? How often are they incomplete? How much human review do they trigger? What is the expected daily or seasonal volume? That is where enterprise realism begins. The document set itself shapes the system design. In prototype work, teams often think in terms of single runs. One file goes in, a result comes out. In production, that mental model breaks down quickly because real systems deal with volume, concurrency, delays, retries, and changing workload patterns. That is why scaling, queues, and retries matter so much. If jobs arrive all day from multiple systems, the IDP platform needs controlled intake, job coordination, workload prioritization, and a safe way for multiple workers to process tasks without collisions. Otherwise, one busy period can create backlogs, duplicate work, or inconsistent job states. A strong production pattern is queue-based orchestration with explicit leases or claims. A worker picks up a job, marks that it owns the work temporarily, renews that lease while processing, and either completes, retries, or releases the job cleanly. If the worker crashes, another worker can reclaim the job safely after the lease expires. That is much stronger than assuming an in-process lock or a single server will always be enough. Retries matter for similar reasons. Cloud calls can fail transiently. Storage may momentarily lag. External systems may throttle. A weak system treats transient failures like final failures. A stronger system categorizes them, applies backoff, tracks attempt counts, and preserves enough state to resume safely. A practical scenario is seasonal or event-driven demand. Some organizations have quiet periods, then sudden spikes. Disaster cleanup, year-end processing, claims events, or large operational cycles can change volume quickly. A system designed only for average load often struggles at exactly the moments when the business needs it most. Production IDP is not just a model pipeline. It is an operating system for document-heavy work. That means it needs elasticity, coordination, and recovery logic, not just extraction accuracy. The last major difference between prototype IDP and production IDP is that production has to live inside the real enterprise. That means integration, auditability, compliance, and accountability all matter. In a demo, the output may be a spreadsheet, a console log, or a simple success metric. In production, the output usually has to update a business system, trigger a workflow, notify another service, support a reviewer, or satisfy a downstream reporting need. That means the output has to be shaped intentionally and traced clearly. Auditability matters because many organizations need to answer hard questions later. What document was processed? What fields were extracted? Which values were corrected? Who reviewed the case? What business rule failed? What was sent downstream? If the system cannot answer those questions, it becomes harder to trust, harder to defend, and harder to operate under scrutiny. Compliance and security add another layer. Different workflows may involve retention rules, access controls, region restrictions, encryption expectations, or legal review requirements. A prototype usually ignores most of that. A production system cannot. Integration also raises the bar. It is one thing to read a value from a page, it is another to pass that value to a finance system, a case management platform, a compliance workflow, or an enterprise data store without creating inconsistency. This is where typed outputs, versioned contracts, and explicit downstream events become important. A weak design treats integration and audit as later concerns. A stronger design treats them as part of the original architecture. That is what allows the business to depend on the result, not just admire the demo. And that really is the central lesson of this whole topic. Prototype IDP proves that the technology can do something interesting. Production IDP proves that the business can live with it every day. IDP gets hard in production because real documents, real workflows, and real enterprise controls expose everything the demo was allowed to ignore. But when teams design for validation, exceptions, review, scale, and auditability from the beginning, IDP becomes far more useful and far more credible. Explore more at ain.net.com. Thanks for watching.